Good evening, my GMT20240713 students. I'm going to go ahead and do the chapter 11 recording. We're going to start talking about market structures. So I'm going to record these lectures. The market structures have to be done by early next week because next week, I'm going to switch to macroeconomic topics. We should be done. So now they have 4 short chapters that I'm going to be recording. The first one is a little bit longer, which is a chapter on perfectly competitive institutions, perfect competitive markets. Then we're going to talk about oligopoly, which is another market structure. We'll talk about monopoly, a market where there's only, or an industry where there's only one seller or one producer of a good. Then we're going to talk about monopolistic competition. So anyway, so the key idea here is that we're going to talk about these different types of industries. So you get to understand if you ever become an entrepreneur and you form up your own company, the first thing you want to know is that which industry does your company lie? Because it has got implication for profit maximization or how much money you make. Okay, like it's always true when you enter an industry where anybody can enter, where there's free entry. Okay, you just know that an industry where anybody can start a business in, there's not a lot of money to be made out of it. I'll give you one example. The market for lawn mowing. If you start up your lawn mowing company, you're not going to be a billionaire. Okay, that's not an industry that produces billionaire, because the skills that are required for you to be a lawn mowing, to start on a lawn mowing company, anybody can do it. It's not like rocket science. So there are no billionaires in the lawn mowing industry. Just know that. Okay. But then there are industries where there are very few sellers or producers of a product, and it's very difficult to penetrate. So it requires like some little bit of genius or people who have a lot of skills, entrepreneurial skills, to start business in those industries. One of them could include things like the computer industry. How many computer companies are there in the United States? Trust me, you can count them. You can count Dell, HP, you know what I mean, Apple, and a couple more. And you're not going to go beyond 20. That's it. Okay. So that means the industries where there are very few firms, very few companies within that industry, that means there are barriers to entry. That's the reason why there's not a lot of producers in that industry, because it's not easy to start a computer company. And you can name a few more. The automobile industry. How many car companies exist in the United States? You can, again, count them. So it's not like you can wake up any morning and say, okay, I'm going to start a car company. I'm not saying that you can't, but it's very difficult. Okay? It's very difficult to enter such industry. And then there are also some industries where you may be alone, when there may be only one firm. And that's what we call monopoly. So that one firm is going to dictate all the prices it charges to consumers. And consumers don't have a choice, because a company could be producing a good which has got no close substitutes. For example, if there's a pharmaceutical company that might be producing insulin, where insulin is a drug that most diabetic patients need. So they can control the price of insulin the way they can jack it up. If you're a diabetic patient, you don't have a choice. So we will talk to, so this from now we're going to start talking about profit maximization in those different types of industry setup. So the industries have different characteristics. Okay, so the first one that we're going to be talking today is what formed the basis of the U.S. economy, a free market economy, which is based on competition. We're going to talk about a perfectly competitive market or a perfectly competitive industry. In a perfectly competitive industry, just before I open the slides, this is going to be an industry where there are so many firms, so many companies, and there's so many producers and sellers, producers and buyers of the product, so that no single seller or producer can control the market price. In fact, in a perfectly competitive market that I'm going to be talking about today, no seller sets the price of their product. Sellers don't have control over price setting. So if you're the producer or a seller in that industry, you produce your goods, the market price is determined by the market. The market determines the price, not a single producer. So if you try to sell your product at a price above the market price, nobody's going to buy your product because the consumers know what the market price is. That's what the characteristic of that industry. Okay. And there's no point of you selling your product below the market price because all your output is going to be, you can sell all your output at the ongoing market price, but you can't set a price above the market price in that industry. So today, we're going to talk about decisions faced by firms based on their costs, their revenues, and when they should enter the industry, when they should exit the industry, when they should shut up, when is the right time to shut down your industry. When we're going to talk about that, there's a case when the price of your product is equals to its average cost or below average cost of producing that good. Then you need to shut, that we call the shutdown point. Okay. So, and then we talked about the point of profit maximization. Okay, so I'm going to share my screen and then we'll talk about it on the other side. So let me share my screen here in a sec. Okay. So here's going to be, we're going to talk about cost and profit maximization under competition. Okay. So here's going to be your outline or the learning goals. We're going to talk about what price to set that a firm is going, of course, there's no price setting by individual firm here. They follow the market price. And then we'll talk about how firms maximize profits. Okay, you guys know that profit is the difference between revenue and cost. So we talked about that. What quantity to produce, and then profits and the average cost curve. And then we're going to talk about the entry, exit, and shutdown decisions. We shall also talk about entry, exit, and industry supply curves. And then, of course, I'm going to wrap it up with some takeaways. So to begin with, we know that every producer or seller of a product must answer 3 basic questions. If you own a company, I know some of you have ambition, maybe you already own a small business. But if you have not yet, you don't yet own a business, or maybe your family owns a business, your family business, whoever runs it, manager, your dad, whatever, your mom, they're looking at what price to sell the product to set, what quantity to produce, and when to enter and exit the industry. So this chapter will look at the answers for a competitive industry. I'll talk about that. Then the later chapters will talk about other industries like monopoly, okay, an industry characterized by monopolistic competition and oligopoly. Okay, so in a competitive market, producers are price takers. So I said that already in the preamble. In a perfectly competitive market or industry, there are so many sellers and buyers, and no single seller can set the price. So sellers or producers are price takers in the sense that they go with the price that the market determines. So the firm is going to accept the price that is determined by the market, and a firm can sell all its output at the market price. A firm cannot sell any product at a price higher than the market price because every consumer or buyer of that product knows of the market price. If the market price is $30, every buyer knows that they need to buy that product at $30. If you set a price at $32, the consumer is going to just pass you around and they go buy from somewhere else where it's $30. A firm has no reason to sell at a price lower than the market price because they can still sell all its output at the market price. So you don't have any reason to sell your product at a lower price than what the market is giving. So the firm's demand curve here is going to be perfectly elastic at the market price. So let me compare. Okay, let's talk about the world market for oil. Let's say that the market for oil is characterized by several producers of oil. So at the market level or at the industry level, the oil industry or market level, the supply curve for oil, for the market supply curve for oil is going to be what? Upward sloping, just like any normal supply curve that you have seen in the past. And the demand curve is also a normal downward sloping demand curve. So let's say that the interaction between the world supply of oil and the world demand for oil determines the price of oil at $50 per barrel. A barrel of oil is $50. And then at that equilibrium point, you can see that 82 million barrels are produced. Say maybe in a year, I don't know. But if you're looking at the demand for just your oil, for one company, the demand for one company's oil is perfectly elastic. This is this horizontal line, meaning that each farm is going to take the market price as predetermined. The market price is given, so you don't dictate the price. So all you got to do, you can supply any unlimited quantity of barrels of oil that you may want. Okay, they're all going to be demanded at the same price. Okay, so again, I want to talk about long run and short run. So long run in microeconomy is going to be the time after all exit or entry decisions have happened. Short run is the time before exit or entry can occur. Okay, when you say you're just trying to decide to enter an industry and start a business, or you're trying to start your own lawn mowing company. So this industry that I'm describing is similar to a lawn mowing company. So an industry is competitive when firms don't have much influence over the price of their product. That's what it is. Because anytime you try to set the price higher than what people know they should buy the good, you're going to lose the customers. So this is a reasonable assumption when the product being sold is similar across sellers. So in a perfectly competitive industry, we're assuming that sellers or producers of this good are going to produce homogeneous products, meaning that the products are identical. So if I buy from seller A or producer A, the good looks exactly identical from the goods that are coming from seller B or producer B or C or D or E. So it doesn't matter really where you buy the product from, they look identical. If I hire company A to mow my lawn, the service product is going to be almost identical to hiring company B, just mowing the grass. Okay. If I buy coffee beans from company A, coffee beans look similar. You don't like this coffee bean, you know what I mean? They look identical. So then there are going to be many buyers and sellers. So each small relative to the total market. So every seller in the marketplace is too small relative to the size of the market. That means they don't have an influence over price. And the buyers as well. Buyers are so many, so each buyer does not influence the market. And there are many potential sellers. I talked about this already. So the market demand is most elastic in the long run. In the short run, it's relatively inelastic. So just your self-check. In a perfectly competitive market, a firm will set its price. Okay? It sets its price equal to the market price. That's like saying that the firm doesn't set its price. It is a price taker. You set the price that must equal to the market determined price. Okay? So the correct choice there would be C. Firms in a competitive industry are price takers and must accept the market price. So they must set the price that must equal to the market price. There's also what we're going to call sunk costs. Sunk costs are some kind of historical costs which cannot be recovered. Okay? So sometimes when you start a business, you're going to incur certain costs that are irrecoverable. So any cost that is irrecoverable, that you cannot recover, must be ignored by the company. Okay? So sunk costs are never relevant because they cannot be changed by any choice. So at some point, you need to just ignore it. So the general principle of rational choice is that ignore what you can't change, focus on what you can change when making decisions. So a sunk cost is a non-recoverable cost. So since you can't change or recover sunk cost, it should be ignored. And then there are two types of costs in economics. In economics, we consider two types of costs. Explicit costs, which is basically the direct cost that requires a money outlay. For example, when you say, well, I need $1 million to start my business. That business is the $1 million is gonna be, maybe part of it's gonna be used to purchase a building which is gonna house my business, to pay labor, to pay capital, those kind of stuff. That's direct cost. But but there's also another cost that economists, which we normally consider, which is the implicit cost. The implicit cost, you can call it, or sometimes called what? You can call it the indirect cost. Indirect cost. This is direct cost. Explicit cost is direct cost. So, a cost that does not require all the money is an opportunity cost. So I'm going to give you one example. If you had $1 million of your own money saving in your bank account, and you took that $1 million and dump it in a small business that you're starting today, okay? So 1 million has already counted as a direct cost to your business because that's how much it costs to start that business. But the implicit cost or the indirect cost is going to be the opportunity cost or what you should have done with that money. Think about it. If you took away $1 million from your savings account, there's going to be a cost associated with that because that money used to earn some interest. Let's say your bank was paying you 5% on a saving account, on your interest payment on your savings. If you took that money out of your savings account and start a small business, that money, there's no money left in your savings account anymore. So the interest rate that you're going to forego, okay, because you've taken the money away, is no longer earning interest. It's what we call the implicit cost. Okay. A cost that doesn't require an outlay of money. It's an opportunity cost. Opportunity cost is the best alternative foregone when you make a choice. So you make a choice to take $1 million out of your savings account to start a small business. While the $1 million is going to count as a direct cost or explicit cost, there's going to be additional cost too, like the interest rate that you're going to forego, that you're going to lose because you've taken the money out of the savings account. Accountants, okay, so there's a big difference between accountants and economists. Accountants, when they're doing their accounting costs, they only consider explicit costs. Accountants don't consider implicit costs. Economists consider both explicit and implicit costs. So that means the profit that is going to be reported by an accountant is going to be much higher than the profit that would be reported by an economist. Because the profit, is a difference between revenue minus cost. And since accounting cost only includes explicit costs or direct costs, that means the difference between revenue and cost is going to be much larger than economics profit. Economic profit is going to consider, you have to add explicit costs and implicit costs and subtract them from what? From revenue. Okay. So that's what I put here. So maximizing profit requires taking into account both explicit costs and implicit costs, the cost of foregone alternatives. So accountants, I said, don't consider all opportunity costs. So accounting profit is usually greater than what? Economic profit. Economic profit consider the best use of the firm's assets. Firms want to maximize economic profits over accounting profits. Okay. So accounting profit, you take, as I said, you take total revenue minus explicit costs. They only consider one cost, the direct cost. Meanwhile, economic profit is total revenue minus total cost. Would that total cost also include implicit costs? It's both a combination of explicit and implicit costs. So here's some self-check. Economic profit is total revenue minus, the answer is C, I just talked about it, both explicit and implicit costs. If the question had asked you, they would have written here accounting profit, then part A would be the correct answer. Because accounting costs only include, accounting profit only considers what? Explicit costs. So now let's talk about fixed costs. So when you incur total cost of operating a business, we can break that cost into two parts. The first one is what we call fixed costs. So fixed costs, these are costs that do not vary with how much you're producing. It does not. For example, the cost of maybe a rental cost of a building where your business is housed. Okay. Let's say you own a pizza business and you rent a small building. Okay. Whether you produce 10 pizzas, 200 pizzas, 300 pizzas, the rent is going to be the same. So that cost is fixed, regardless of how many pizzas you produce as a company. But then the second cost we're going to talk about, they can't be changed by short-run choices, so they should be ignored in the short run. They can be changed by long-run choices. So long-run choices basically mean that if in the long run, when a company wants to expand, then they may want to maybe lease a second building. So you could vary them in the long run, not in the short run. Okay. And then the other one is variable cost. Variable costs vary with output. So things like labor costs, cost of paying labor, that's a variable cost. If you own a pizza company where you hire one person to make pizza in your small business, that one person can make you what? 50 pizzas a day. If you hire the second person, maybe the two individuals can make up to 80 pizzas. So you can see the cost increases as you increase the number of employees. So labor cost would be a variable cost. These are costs that vary with output, how much output you're producing. Cost of raw material goods. Of course, if you're producing many pizzas a day, then the cost of buying the pizza dough, meat, pepperoni, and the ingredients that go into making pizza, okay, they will vary with the size of the number of pizzas that you want to produce. So all those are going to be cost of raw material goods, cost of labor, all variable costs. So the profit, the formula for profit is you take and our notation for profit in this class is pi. Pi is a Greek letter of alphabet. So pi is our notation for profit. So profit is total revenue minus total cost. But what is total revenue? Total revenue that a company gets, you take the price per unit of a good. Let's say you own a pizza company and you produce 200 pizzas a day, and each pizza is $10. So that means your total revenue per day is going to be $2,000. $10 per pizza times the 200 pizza. It's your revenue. So the total cost is the cost of producing a given quantity of output. It includes fixed costs, which does not vary with the level of output, and variable costs, which vary with output of costs. So in other words, what I'm talking about, I'm going to say that total cost equals to variable cost plus fixed cost. Okay? All right. So for short, Q is going to represent our quantity as before, and P is the price. So TR stands for total revenue. So total revenue is price times output. So again, total cost is the cost of producing a given quantity of output, right? We just talked about that. And then we're also going to start defining certain key concepts. And one of them is, when we talked about the word at the very beginning of this class, we talked about marginal analysis. So one of those marginal decisions at the margin that a lot of times when firms or individuals are making decision to do something, it's not like they're starting from scratch. It's decision to do a little bit more or a little bit less of an activity. So there's so many marginal variables that have the name marginal in economics. One of those is what we call marginal revenue. So marginal revenue is a change in total revenue from selling an additional unit. So they're basically saying that, let's think about it. If you were producing 200 pizzas, like I said before, and a price of pizza is $10, so your total revenue was $2,000. What about if you sell one more pizza than you normally do? Let's say you end up producing 201 pizza. So that means 201 times 1 times 10. That means your revenue is going to be now 201,000. Okay, 2001. Okay, so the change in revenue, which is now how much you sell because you produce one additional pizza from what you were producing before, which was 2,000, is what we call marginal revenue. So the formula is very simple. Marginal revenue is going to be equal to change in total. So delta there is in this class. When I say delta is a Greek letter of alphabet. In economics, when we use delta, that means we're talking about change. So delta, so this you can write this in full and saying change in what? Because delta means in change in total revenue because TR is total revenue, divided by change in output, because Q is output. So marginal revenue, again, is the additional revenue that a firm derives from selling one extra unit of the good. Okay? So for firms in perfectly competitive markets, marginal revenue is always equal to price. That's right. Marginal revenue is always equal to price. Okay? So if the price is $10 and you sell one extra unit of the good, that means additional revenue is going to be $10. That's why price must equal to margin, because the price in a perfectly competitive market tend not to change. Because since firms are going to sell their product at a market-determined price, and market-determined price tend to be constant. So for every additional pizza that you're producing, it's going to be sold at the same price. So that means, in a nutshell, the additional revenue that the firm is going to get is going to be the same thing as the price of the what? The price of the output. And then just like we have marginal revenue, we also have marginal cost. So marginal cost is a change in total cost from what? From selling an additional unit. So anytime you try to produce and sell one extra piece as a company, it doesn't come for free. You incur some cost. Because typically when you are producing 200 pizzas, it would cost you a certain amount of dollars. Should you try to produce one extra pizza to take it to 201 pizza, the additional cost that you're going to incur from producing that one extra unit of pizza is what we call the marginal cost. Okay? So marginal cost is, again, is going to be equals to change in total cost as a result of changing what? Change in output. The additional output that is going to be so in full, again, you can write this as change in total cost. TC stands for total cost, delta stands for change, divide by change in output. So when a firm decides to produce one extra unit of pizza, the cost of that additional unit of pizza is what we call marginal cost. Again, now to maximize profit there's a condition for profit maximization in a perfectly competitive market, and that condition is here. That for profit to be maximized in a perfectly competitive industry, it happens at a point when price equals to marginal cost. So anytime price is greater than marginal cost, firms are going to continue to produce more output, because that means they're selling that product at additional at a price, selling that product at a price which is higher than the cost of producing it. So they're going to continue expanding output up to a point where price equals to marginal cost. That's going to be the point where the profit maximizes. Beyond that point, firms may start losing money. So a profit maximizing firm and a perfectly competitive industry is going to produce up to a point where price equals to marginal cost, because that's a point of profit maximization. Keep in mind that the profit function is a quadratic function. Okay? Typically, the profit function, look, when I talk about the profit function, it kind of looks like this. It's not a linear function. So if I'm trying to look at, let's say, profit on this axis versus output, profit function is going to increase and it's going to reach a maximum. And then profit is going to start declining. So firms are going to want to produce up to the point when profit reaches a maximum. See? So the point where this output that you produce when profit reaches a maximum correspond to a point where the price you're going to sell that output equals to the marginal cost of producing it. Beyond that point, that maximum point, any additional output you produce is going to trigger less profit. So that's is a non-linear function. It's quadratic. So the firms are also going to be faced with the decisions of what quantity to produce. So since profit is a difference between total revenue and total cost, maximizing profit means maximizing the difference between total revenue and total cost. So here's going to be the two ways that we determine profit a point where firms maximize profit. The first method, you are going to calculate total revenue separately. I might give you a table. That table is going to have price information in one column. It's going to have quantity information on one column. So from that, you can multiply price times output for each output, multiply price times output to get the total revenue. And then that table might also have information on cost, how much it costs to produce each unit. Okay. So you're gonna look for calculate total revenue and total cost, and then look for the quantity that maximizing a difference, because profit is a different. It maximizes the difference between total revenue and total cost. That's a point of profit maximization, when the difference between total revenue and total cost at its maximum. Okay. I'm going to show you an example on the table shortly. If you don't want to go through this method to show which point should a firm maximize profit, the second method also is very easy. You're going to compare the increase in revenue from selling an additional unit, what we call marginal revenue, with the increase in cost from selling an additional unit. And then the point where marginal cost equals to marginal revenue is going to be the point of profit maximization. So let me show you this information here. So this is saying that this is an oil producing company. So on this column here, you can see clearly it's listing the barrels of oil produced by a single company. Okay. And then I guess we have been given the price of what? The price of oil was here. We had been given it before. With the price of oil, barrel of oil was $50. Remember, we're using that same example. So if P doesn't change, P is $50. If a company produces zero output, 0 barrels, it's gonna get 0 revenue, total revenue. If you produce 1 barrel of oil, each barrel is $50. So 50 times 1, because total revenue is price times output. Price is $50, output is 1, that's 50. If you produce 2 barrels of oil, you multiply price, which is $50 times 2 barrels. That's $100 in total revenue. You produce 3 barrels of oil, you're multiplying price times quantity, which is 50 times 3, which is 150, and so on and so forth. And then you're also going to figure out total cost. How much it costs to produce each output. Okay. So the total cost has been given here for you already. Okay. To produce 0 output, it costs you $30. That's what we call sunk cost. So even though you might have an oil company that maybe they just bought land, oil fields, but so the money they spend for buying like land, maybe setting up refineries, setting up like oil drilling, oil drilling plant, those kind of stuff, it's going to cost them some money before they even start producing, what we call sunk cost. So it costs them already $30, right? Even before they start producing anything. And then you can see to produce 1 barrel of oil, it costs them $34. To produce a second barrel of oil, it costs this company $40. To produce a third barrel of oil, it costs the company $51. And so on and so forth. So you can see that, for every, okay. So total cost is definitely rising for every additional barrel of oil produced. So once we know what the total cost is here on this axis, on this column, on the total revenue, which is the difference between total revenue and total cost, is your profit. Profit is TR minus TC. So for the 0 unit produced, total profit is going to be equals to total revenue minus cost. 0 minus 30 is negative 30. And then for you to produce the first unit, total revenue is $50, but it costs you $34. So the profit is going to be 16, revenue minus cost. The third unit, your revenue was $150, but it costs $51 to produce it. So the profit is $99, and so on and so forth. Okay. Now you can see the point I was telling you, that the profit function is a quadratic function. It's a non-linear function. So you can see profit is certainly rising. It rises, then it reaches a maximum point like 194. Then it starts declining. Okay. Now, as I told you, you are going to look for a point where profit is maximized, where the difference between total revenue and total cost is maximized. And so there are 2 numbers here. 194, 194 here. Okay. But we need to look at what we need to look at first. We look at the last number in this case because we're maximizing it here. But to check that you are correct, because we're saying that the way we want to determine the point where a firm should profit maximizing level of output is not going to be this output 7, is going to be 8. Why do we pick 8? We must also compare the what? The marginal cost and marginal revenue. Remember, marginal revenue is change in total revenue minus change in total cost. So how do I get this 50? Remember, there's no change here because that's where we're beginning. So we start from 0 to 1. Remember, your revenue went to what? Change in revenue when you went from 0 to 50 is going to be 50. So change in revenue would be 50 minus 0 divided by change in output. Output is 1 minus 0. See, so the first marginal revenue is going to be 50 because marginal revenue is change in what? Total revenue divided by change in what? Output. And then we go for the second unit. See, revenue is 100. So change in revenue from the previous is going to be 100 minus 50 divided by change in output 2 minus 1. So you can see, in this case, your marginal revenue is always going to be constant for a perfectly competitive firm. See, marginal revenue is constant, 50, 50, 50. And then we're also going to figure out what the marginal cost is. Marginal cost is change in total cost divided by change in what? Change in output. For the first unit here, the 0 output, because we don't have anything prior to compare the change, there's going to be just a dash and it's not available. So the change starts from the first unit when the firm starts to produce the first barrel of oil. So we want to see how cost changes as you produce additional output. So you can see that the total cost of producing 1 barrel of oil was $16. The total cost of producing let me say where is it? No, so I'm sorry. Total cost is gonna be where's my total cost? I'm looking at staying at it's 34 actually for producing 1 barrel of oil. And then we're comparing with the cost when you were producing 0. So the change in cost is 34 minus 30 divided by change in output, which is 1 minus 0. So that's gonna be 4. And then the marginal cost for the second unit produced, it cost the company $60. No, I'm sorry, $40 here. That's the total cost. So the change in cost is going to be 40 minus what? Minus 34, which is 6, divided by change in output, which is 2 minus 1. So that's going to be 6. And you're going to do that so on and so forth. So this is going to be just take change in what? Change in total cost divided by change in output for every output produced. And then the condition for profit maximization, if you want to determine which output maximizes profit, which was the second method, you're going to compare the column, which is your marginal revenue column and your marginal cost column. The point where the marginal cost equals to marginal revenue is going to determine the point where the firm maximizes profit. You can see there's a point where the marginal revenue is 50 and marginal cost is 50. That's the only point where they equal. So that means the profit maximizing output here is going to be 8 when the farm produces 8 barrels of oil. I don't know whether it's in 8 million. I've not been in the unit of measurement. We just go with 8. Okay. Beyond that, the farm is going to make losses. You know, if this farm decides to produce beyond 8, let's say produce 9 barrels, you can see the total cost now is going to be 296 for the 9 barrels of oil. And yet total revenue is only going to be what? Total revenue is still going to be 450. So that revenue is not going to be that profit is not going to be maximized compared to the previous profit. You see, this is the best profit is still profit is going to be under 94. Okay. So the best, I would argue that the best way to, when I ask you a question on the test, determine the profit maximizing level of output. When I give you a table like this, and maybe ask you to calculate those whatever, you just look for a point where marginal cost. You look at the marginal cost column and compare that with marginal revenue. The point where those two are the same, marginal cost equals to marginal revenue, determines the output that maximizes profit. Okay. So what quantity to produce? So keep producing so long as marginal revenue is greater than marginal cost. That's right. Anytime marginal revenue is greater than marginal cost, that's a signal that the firm still has profit margins remaining. So they still need to continue producing. But remember, as you produce more output, your marginal revenue stays constant. Your marginal cost rises as you produce more what? More output. You've seen that on the what? On this table. Marginal cost is rising for every additional barrel of oil that this company is producing. So there's gonna if you started with a point where marginal revenue was greater than marginal cost, since marginal cost revenue doesn't change, but marginal costs keep rising, there's gonna reach a point where marginal revenue equals to marginal cost. As you saw that unit 9, output 9 is gonna be the point where they descend. So when firms produce where marginal revenue equals to marginal cost, they maximize profit. So that's the profit maximizing condition, not only in the perfectly competitive market, but in any market out there. I'm gonna show you later, that's gonna be the same condition in monopoly, in oligopoly, and maybe in what? But a monopoly can produce at a price greater than marginal cost. But the profit maximizing condition is still gonna be the same, that marginal revenue must equal to marginal cost. Whether monopoly or oligopoly, monopolistic competition, and these perfectly competitive markets, same thing. So here's your self-check. A competitive firm will maximize its profit at a quantity where marginal revenue equals to marginal cost. That is true. That's the correct answer there. Okay, we just talked about it. So let's put it in diagram. So what we just illustrated in the table, we can transfer that information here. If we plot your marginal revenue, remember your marginal revenue stayed constant. See that? It was constant all through. Where is the marginal revenue? See this? It's constant, 50, 50, 50 all through. But your marginal cost was rising as you increase what? So if I plotted combinations of these barrels of oil and how much the marginal cost of producing them, you can see that marginal cost curve is gonna kind of like be upward sloping. See, it's gonna rise, meaning that the cost rises for every additional unit you produce. But marginal revenue stays the same. See, that's why it's flat. For every additional barrel of oil you produce, it costs the same, $50. And the point of profit maximization is where those two lines intersect, where the marginal cost curve line and the marginal revenue line intersect, which is this point. So when that point, you're saying we're just gonna read, this is gonna be your maximum profit maximizing output level, which is 8 barrels of oil for this company. So it's pretty straightforward. So as the firm changes, price changes, so does the profit maximum quantity. If price increases, the firm will expand production for sure. Okay, so we know that. So if a price increases, the firm will expand production. That's true. Because every firm wants to, I don't know why some mistake cycling this. The correct answer is what? Is A. If the price of is rising, that is a sign that the firm's profit is also going up. So they need to increase what? They can make more revenue or make more profit by selling more. So they're going to expand production. Now let's talk about another types of cost, which is average cost. So the average cost of producing, when somebody say the word average, you know that the word average is different from the word marginal. So the average cost, you take total cost divided by output. Okay. So a firm can maximize profits and still have low profits or even losses. Remember that. It can be useful to show profits in what? In a diagram. So the importance of average cost is that it helps us to show the point of profitability in a diagram. Because we need to know the average cost of producing that output. Then we need to know the what? The marginal revenue and marginal cost to determine the point of profit maximum, where the firm is actually maximizing profit. So to do this, we need average cost, which is cost per unit. We can then calculate profitability. So I'm going to show you shortly here. So profit, okay, to show you what is going on here, we know that profit equals to total revenue minus total cost. Okay. And then what we can do some little bit of mathematical magic here. We can divide all through. I skip one step here. You can divide all an equation. What you have done on the left, you must do on the right. If I divide all through this expression by Q, that means you can write this as profit. An equation, what you have done on the left, you must do on the right. Right? Write it as profit divided by quantity Q mass equals to TR, total revenue, divided by Q, minus total cost, divided by Q. I've not changed anything. All I did is just divide all through this equation by quantity. And then the next thing, I'm just going to multiply both sides by Q. If I multiply both sides by Q, I'm going to come up with this equation. Multiply both sides by Q, times Q, then this is going to be times Q. So Q is going to cancel. So you come up with this equation here. Profit equals to TR over Q minus TC over Q, close bracket, times Q. And then we also know that what? Total revenue equals to price times output. We know that. So we can substitute this guy here, where there's total revenue, because that's a formula for total revenue. So that means your next equation, if you substitute that, your TR becomes P times Q divided by Q. So that's going to be profit here equals to that minus TC over Q, everything times Q. That's right. Okay. So now you can see Q can cancel. Okay. Total cost divided by Q, that is what we're calling average cost. That's right, because average cost is what? So see, Q cancel. TC over Q, that is average cost we define. Average cost is total cost divided by output. Okay. So then now your profit is equal to P minus AC times Q. So that's one way. So we end up with that. So profit, so you can see that profit is going to be the profit that you make is going to be determined by the difference between the price of your good, of the output you're selling, and the average cost of producing each unit. Of course, then you multiply it by the quantity that you're going to be selling. So that means the difference between price and average cost is very crucial in determining the profitability. So think about it. If the price was high and average cost is low, this difference is most likely going to be big, so that for every addition, for any output that the farm sells, profit is going to be higher. But if the price is too close to AC, think about it. If price equals to average cost, then profit is zero. And we're going to talk about the implication that you need to shut down as a company. Because when P equals to AC, then P minus AC is zero. So 0 times Q is 0. So profit is going to be 0. Okay. So the only time a farm maximizes profit, it has to be the case that the price has to be greater than AC. If a farm starts to continue to produce when price is less than AC, that is insanity, because now profit is going to be negative. If P is less than AC, P minus AC is going to be negative. Negative times Q is negative. Negative profit is you're making a loss. So that means the difference between price and average cost determines whether the farm should continue producing or it should shut down. So what I'm going to discuss next, okay? So this formula tells us that profit is equal to the average average profit per unit times the number of units sold. Okay, that's right. Okay, so let's go back here now. We can calculate our what? We can calculate our average cost. Average cost is, average cost, you just take total cost divided by what? By the output. Of course, for the first unit, is 0. We don't have anything. The first unit is going to be, you take total cost, which is 34 divided by 1, that's 34. The second average cost, and the next average cost, you're going to take 40 is the total cost divided by the units, which is 2. 40 divided by 2 is 20. And the second average cost, you're going to take the total cost is 51 divided by 3, that's 17. I mean, so this is how you compute this, your average cost. This column here represent, the last column here represent average cost. So now you can see because we know that price is always equal to marginal cost in a way, in a perfectly competitive industry. So think about it. So if we I want us to find a way of locating a point where price equals to what? Price equals to, but look at the change in profit itself. So the change in profit is changing for every unit that you produce, right? Change in profit, right? Until when you hit this point, the profit is now 0. So what does that tell you? If you continue producing beyond that point, your profit is going to be negative. That's right. In other words, your total cost is going to exceed total revenue in a way. So you better not be producing here, because when you, where's your profit again? You want to get the change in profit. Okay, so this is your total profit here. See, you hit 94. Now you fall to 154. So the change in profit is now negative 40. It even gets worse and worse, now negative 74. Okay. So profits are maximized when marginal revenue equals to marginal cost, where Q equals to 8. At Q equals to 8, average cost is 25.75. You see that? That's right. That's the average cost when you're maximizing profit. And profit equals to P minus AC times Q. That's right. Okay. So we can plot that average cost curve like going like that. See that? Somewhere it touches this line at this point. That's when we are producing 25.75. And then we are making this profit. This is a profit margin. This area here, which when you talk about, is going to be this area of this shaded green. All we gotta do is just take the what? Because this is your margin, this is your cost. Yeah, that's right. So profit is basically going to be this area here. Okay, because remember, your marginal revenue is also 50 equals to marginal cost. So that's a condition for the profit maximization, is when marginal revenue equals to marginal cost. That happened at unit 8. And that's going to be the size of the profit that the firm is going to get. Okay. If margin revenue equals to margin cost, doesn't that mean that the firm makes a profit? Okay. Remember, the minimum average cost is 17 at that point. At any price below 17, say 10, price is lower than average cost. That's the losses. So you can think about it here. See, this is your average cost, which is the red line. This is your marginal cost of producing every additional unit of the good. Okay. Okay. Remember so think about it. Okay, this is your marginal revenue. Firms always charge a price equals to marginal revenue. So marginal revenue equals to price always. So because your cost is rising, marginal cost rises for every additional unit of the good produced. An average cost rises, falls, and then it starts rising up to a certain point. You can see clearly that there's going to be a point of where marginal revenue equals to marginal cost. That's a point of profit maximization right here. See that? But in this case, your average cost is above your what? Your marginal revenue or your average revenue. So the firm is going to incur some losses here. So now the idea is that whether the firm makes profit, even if that condition of marginal revenue and marginal cost is met, it depends crucially at the position of the average cost curve. If the average cost curve is above the point of profit maximization, which is marginal revenue equals to marginal cost, or price equals to marginal revenue, which is this point. You see at this point, you see the average cost curve, the red line is above. So that means your costs exceed the revenue you're going to get from selling that output too. But in this case, the firm is going to make losses. You can contrast that with another case. So here's another, so we talk about this. See? So the marginal curve crosses the II cost at its minimum point in this case. So this is going to measure what the point of shutdown, because this is even more severe. Okay, that tells the firm that the price marginal cost is already equals to what? To average cost of producing this good. Okay, So think about it, where if you insert like a margin, let's say the margin revenue line passes through that point, that means the price you're going to be selling this product equals to its average cost. So that means the farm is just kind of like, marginally surviving. So if that means that's going to be like kind of like a shutdown point. Okay. Beyond that point, the farm is going to start making serious losses. That means it cannot even cover the average cost of producing that good from the revenues generated from selling that output level. Okay. Beyond that point of shutdown, a farm cannot cover its average cost of producing the good. Okay. Okay. So this kind of like more repetitive. Marginal cost pulls AC down if it lies below it. Okay. See that? So if marginal cost lies below AC, we know because price equals to marginal cost and is less than AC, that is a loss. I talked about it. If you're selling your good at a price which is less than the average cost of producing it, then you need to shut down. In fact, the shutdown point has to be a point where the price you're charging must at least be able to cover the cost of producing that good, the average cost of producing it. That's right. If it costs me $5 to produce this glass of water, the average cost of producing this glass of water is $5. That means the price I must charge must at least be $5 or more. Okay, if the price is less than the average $5 that I incurred producing this glass, then what I need to do is to shut down. That means not profitable anymore. Okay. So if a firm produces at a point where marginal revenue, marginal cost, it will always make a profit. That is false. It depends on where the price it charges for the good. If the price is less than average cost or equal, that means the firm is making a loss. Or if the price is great, if the price is greater than average cost, yes, the firm will be making profit. Okay. So the answer is false. If average cost is greater than price, the firm will have a loss. That's what we talked about. So, even though we're saying that marginal revenue to marginal cost is a crucial point of profit maximization, but that ultimately also depends on the price the firm is charging for its product. If that price is below the average cost of producing it, then the firm is making a loss. Okay. So firms seek profit. So in the long run, firms will enter the industry when price is greater than average cost. Firms will exit the industry when price is less than average cost. There's less than sign here. I'm sorry, I went through this before. And then, but when price equals to average cost, profits are zero, and there's no incentive to enter or exit. That's right. But anytime you run a business, some of you are going to start your own business. Doesn't matter. Anytime the price of your product rises above the average cost of producing it, you got to get the hell out of the industry. Shut down means you need to shut down that company. The only way you stay in a business when price is greater than average cost. So zero profit means that the price is just enough to pay labor and capital, the opportunity cost. So zero profit really means normal profit, okay? So zero profit means the firm is neither making a loss nor making profit. The firm is just break-evening, okay? And in a perfectly competitive industry, we believe this is always true in the long run. Because in the short run, many firms tend to join this industry. But in the long run, the cost is going to rise for everybody. Then some firms are going to exit the industry. So firms that remain can only break even. That means their cost will equal to their revenue. Their profit is going to be zero. So anytime profit equals to zero, we call it zero economic profit, okay? Or sometimes we call it normal profit, okay? We are going to contrast this with firms in other industries, like in monopoly. Monopoly can make abnormal profit or non-zero profit, meaning that their profit can be, positive profit can be even in the long run, because they are the only one in the industry, okay? Or firms under oligopoly market structure, because there's barriers to entry. There's not, because the idea about perfect competitive, where if you ask me, why would farms only make zero profit under this market? The idea is that it's so easy to enter this industry. So when other farms see when people see other companies making money, like say in the lawn mowing industry, then people are going to join because it's not difficult. It's not rocket science to join a lawn mowing industry, as I said in the beginning. So as more and more farms join the industry, they're going to share away the available profit until when no profit is available, no profit opportunity. So they reach a point where they can only break even, meaning that they can only be able to cover their costs. So typically, exit cannot occur immediately. We know that total cost equals to variable cost plus fixed cost. In the short run, a firm must pay its fixed cost, whether it is operating or not. You know that. Fixed costs are going to be the cost of like rental. You need to, if you're renting a building, let's say you own a pizza company and you rent a building. Whether you produce pizza or not, you must pay rent because you're already renting that building. If you took out a loan from a bank, the interest on that loan, you need to service that loan, whether you start producing or not. Okay, so fixed costs therefore do not influence decisions in the short run. The firm should shut down immediately only if total revenue is less than the variable cost. If you cannot cover the cost of labor in the short run, the cost of raw material goods, you need to shut down immediately. So that also leads us to the last types of costs, the average variable cost and average fixed cost. So the variable cost is a cost per unit or the total variable cost of producing Q units divided by Q, right? Because we know total variable costs are costs that vary with output. When you produce more output, that cost rises, like the cost of labor. You want to produce more pizza in your company, you better hire more people. So the cost of hiring more people is going to vary with the number of pizza. The other cost, you're going to vary with the number of pizzas you're producing. Then that's what we call a variable cost. So the average variable cost, you're going to take that total variable cost divided by output, just like we talk about average cost. And then the average fixed cost, you take the total fixed cost divided by output. Okay. Okay. So here's some key takeaways though. We know that if price falls below the average variable cost, then the firm should shut down immediately. That is true too. Because a variable cost is a cost that you incur for paying like labor, raw material goods. So if the price you're even charging for your pizza is below the average variable cost of producing it, that means that price, the revenue you're getting from selling that pizza is not even enough to cover the cost of labor or the cost of raw material goods that should help you produce that pizza in the first place. In that case, you should shut down immediately. So if price is above average variable cost but below average cost, then the firm should continue producing, but exit as soon as possible. That's right. If price is at or above average cost, the firm should continue producing where price equals to marginal cost or enter if it's not already in the industry. That we know that. So if price is at or above average cost, that means you're still making money. Okay. So those are the decisions you face when you are the firm trying to either shut down or try to enter the industry. Of course, just hold on a second. I'm trying to my diagram there looks a little messy. So let me open another slide, which is a lot more cleaner. Okay, there you go. Okay. So let me share my screen here once more. Which one did? Okay. No, I don't want to share that. Just let me share this other one small. Okay. Okay, so this is a clean version of it. Why is it not? It's not downloading. Oh, just give me a second here. Okay. Now I should share. What I need to do is just close this one. Then go and close this guy. Now I should be able to share the clean version. Okay. So let's go back here. Oh, pull out the nasty version again. Just 1 second, guys. Modules. Chapter 11. And then okay, let's go back and share my screen now. Hopefully this works. Unless when I my okay, so yes, it seems there's a clean version here, where there's not a lot of writing markers on the slides. Anyway, so I left when we were talking about that shutdown decision facing the firm when we introduced the average variable cost and average fixed cost. So let's just scroll down to the point. Okay, all this. Okay. Talk about all these. Okay. There you go. This is where we got the average variable cost. Yes. There you go. That's a clean diagram I wanted to show you. Okay. So now here it kind of summarizes most of it. So the point you want to see here is that your average cost curve slopes downwards. It's going to slope downwards, and then it reaches a minimum, then it goes up. The marginal cost curve is you can draw a marginal cost, and then this is your average variable cost, because your average cost curve includes both fixed costs, average fixed cost, and what? An average variable cost. It has to be drawn below the average cost. So your average variable cost is this other second curve down in the middle here. Okay. So what I'm saying is that at a point where your marginal cost it's your AVC here, that is a shutdown. You shut down immediately. Because remember, the firm is the price must always equal to margin. They try to set a price equals to marginal cost. And if that marginal cost equals to the average variable cost, that means the price you're charging for your product is only good enough to cover the variable cost of producing, the cost of labor, cost of raw material goods. You're not making any money. Okay, so you need to shut down at ASP. That's what I'm talking about. Okay, but if you're in between here, you see the yellow, where the marginal costs exceed the average variable cost, but below average cost, you should exit ASP, but don't shut down. Okay, but you're thinking about exiting the industry because you're still not making money overall, because the price you're charging in that case is still what? Is still below the average cost of producing it overall. And then the green place here, when I say green, that means enter the market. Anytime because marginal cost, firms are always going to charge a price equals to marginal cost. So if the price is above the average cost of producing it, that means it's profitable. So many firms are going to enter the industry. Okay, the yellow one, that's caution, meaning that you're about to shut down. Okay, sorry, exit, but don't shut down, right? But anything below that, that is shut down completely. This is a critical point right here. Shutdown point. So the shutdown point, when a firm completely shuts down immediately, is when the price equals up in a point where the marginal cost or the price equals to average variable cost, which is this point here. The slope of the supply curve can be explained by how costs change as industry output changes. So let's talk about, we bring supply in the mix. Supply curves can slope upwards, can be flat, or in rare circumstances can slope downwards. Okay. So we're going to compare, there are two types of industries. There's what we call increasing cost industry. Then we're also going to be talking about constant cost industry, and then decreasing cost industry. So an increasing cost industry is an industry in which industry costs will increase with greater output. It's shown with an upward sloping supply curve. So the idea is that if you have an industry whereby if many entrants join, many firms join that industry, because they're going to start producing large volumes of output, then the cost also rises as output expands. Okay, so that is similar to the upward sloping supply curve that I've already shown you. So costs are going to rise as industry output increases, so greater quantities can be produced only by using more expensive methods. So any industry that buys a large fraction of the output of an increasing cost industry will also be an increasing cost industry. So let's say there was another industry out there that is using the output of one industry as its input to producing output. Then that industry is also going to be, an increasing cost industry, because that means the cost is going to rise as the other industry cost rises as well. So to show you in a diagram, this is what's going to happen. So I'm going to show you two scenarios. When oil is near the surface, like in Saudi Arabia, they just dig a little bit underneath some dirt, and oil is right there. You can see that the marginal cost of producing that oil is only at $17. Okay, to produce 5 barrels, it costs only $17. Okay, and that's going to be the price they're going to be selling a barrel. See that? Because price must equal to marginal cost, right? So you can see price is less than $17. That, when quantity is 0 here. See, you see that? But price equals $17 when you got Q1 plus Q2 equals to 4 when you're here, right? Price equals to marginal cost for producing it. But think about this other scenario too. Oil is located deeper in the ocean. Like this is like offshore drilling that we see in America, which costs a lot more money to drill. As if you try to expand oil production in the United States, it comes with a lot more increasing costs. So it's not as easy as you may think in terms of production. Okay, oil production in the United States costs a lot of money because of offshore drilling. That means the industry cost increases as the oil industry starts to expand output. Okay. And then you can see that for these types of industries, the supply curve for the entire industry is going to be upward sloping. Okay. So the idea is that if oil was located on the surface first, you can think about a case where in America back in the days, maybe we were also drilling from the surface, similar to Saudi Arabia. But as the United States, the oil industry wants to expand more and more, want to drill more and more oil. There's no more oil available on the surface anymore. They want to get more oil. They need to go offshore drilling, drill underneath the ocean. That is more costly. So you're going to move from this scenario to this scenario 1, farm 1 to farm 2. That's the reason why as the farm wants to produce more output, the price or the cost is going to rise with it. So they must also charge a higher price for the additional output is trying to produce it, because it costs them more. You can see that price increases or marginal cost increases as output increases. But there are other industries which the cost does not change, even if firms in the industry try to expand output. We call those constant cost industry. The cost stays the same. There's an industry in which industry costs do not change with greater output. It's shown with a flat supply curve, which is kind of not a perfectly elastic supply curve. Supply curve stays flat in that case. So a constant cost has two characteristics. It meets the condition for a competitive industry. The product is similar across sellers. There are many buyers and sellers, each small relative to the total market. There are many potential sellers. It demands only a small share of its major inputs. The industry can expand or contract without changing the price of its inputs. That's right. Like the cost of, how much does, lawn mowing company. We tend to assume that the cost is the same. Even if as many lawn mowers join the industry, I mean, the size of the output they're producing is increasing. The cost of starting a lawn mowing company might stay the same. Maybe you just buy a lawn mower, the price might be the same. Okay, so a perfectly competitive industry like a lawn mowing company is a kind of similar to what we call constant cost industry. So you can see the long run supply curve is perfectly elastic. It's basically flat. That's right. So that means anytime you have the farm, we try to increase output or increase even demand, okay, the cost is going to stay the same. Okay, cost will stay the same. Then the last one is, so implication for a constant cost industry is that price is driven down to average cost. So profits are driven down to normal levels, So price doesn't change much because average cost doesn't change much when the industry expands or contracts. So prices, and you can see the price of lawn mowing. They typically don't change that much. Unless when some major shock is happening in the industry. So decreasing cost industry, as an industry in which industry costs decrease with greater output, is shown with a downward sloping supply curve, which is not very typical. This is very rare, quite rare. But an example could be a scenario where industry clusters can create decreasing cost industries. Like as the industry grows, suppliers of inputs move into an area decreasing costs, like Silicon Valley, which attracted mostly tech companies in Silicon Valley, California. Dalton, Georgia is known, that's a carpet capital of the world. They produce a lot of carpets there in Dalton, Georgia. So there's so many carpet producers that clustered in that area, because they all move in the same area. There's a way they can drive down costs. So cost reductions are temporary. Eventually, once the cluster is established, like the Silicon Valley has already been established, constant or increasing costs are the norm. Eventually, the costs but as they're clustering, like, here in Austin, we had tech companies move here. But over time, as all those tech giants have clustered in Austin, their costs are going to start rising. So for decreasing cost industry, it's not going to last forever. Like, the cost decreases, but then it becomes constant, then eventually it could rise. But this is an example of a constant cost industry where the supply curve is what? Is perfectly elastic, is horizontal. This is an increasing cost industry, which I showed you earlier. The oil industry is increasing cost industry. So an industry in which the industry costs do not change with greater output is called, of course, that's B, constant cost industry. We talked about that. So there's just a few more takeaway. What price to set? So here are the takeaways. These are some of the decisions that farms face in a perfect competitive market. We already discussed that. So there are a few takeaways that a farm is going to always decide what price to sell, which in a perfect competitive world, there must be price takers. That price has to be equal to the market price. Okay, so the farm sets a price at the market price. What quantity to produce to maximize profit? A competitive farm should produce the quantity that makes price equal to marginal cost. Okay, so marginal revenue must always equal to marginal cost. Okay, because price is always equal to marginal revenue, right? So then if price equals to marginal cost, then that means marginal cost must equal to marginal revenue. When to exit or enter an industry? In the short run, the farm should shut down only if the price is less than the average variable cost. Remember that I showed you that diagram. And then in the long run, a farm should enter if price is average cost, and exit if price is what? Is less than average cost. So I showed you the different sections on the graph. Point of shutdown, point of entry, and points of what? Exits. So profit maximization and entry and exit decision as a foundation of supply curves. In an increasing cost industry, cost rises as output increases. In a constant cost industry, costs remain the same. And in decreasing cost industry, cost is going to fall as as farms clusters, in an area or in a, particular region. So this concludes my discussion of what a perfectly competitive industry is. So make sure you watch this video again take notes. I'm going to be assigning homework, I believe homework 3 based on this material. And then the other 3 chapters were very short chapters. We're going to talk about chapters on monopoly, on oligopoly and monopolistic competition. Okay. So I'll see you guys next time. Thank you.